All right, we left off right here talking about constructors. Now, you probably don't realize this, but so far we've written several payroll programs. All right. If you did the pretest, you wrote a rock, paper, scissors program, and you wrote that guessing game program. Plus, we did a few other ones at the end of last semester. Every time you've written a program, even though you don't put it in, all right, I want to show you this if you look up on the screen here. I don't want that one. So let's see, I want this one. All right, I'm going to come in here and I'm going to create another file. I've got rectangle. Everybody see this? This is how you do it. So you have to watch the screen right now. All right, you have to watch the screen because when you write object-oriented programs like this, all right, when you write these kind of programs, you put main in another file. So what I'm gonna do here is I'm gonna go over right here on my package, right mouse click on it, choose new Java class. I don't put edu.rank because I'm already there. So I'm just gonna put here rectangle driver. All right, and that's gonna create this rectangle driver class. All right, I might end up putting a lot of stuff in here, but let's say that I want to create a new rectangle. All right, so we're assuming right now that I want to create a new rectangle. I'm going to say something like this: rectangle R1 equals new rectangle. This is going to be in a separate file. Did you hear what I said? This will be in a separate file. This file is called a driver. Remember, if you remember, I said that in an ideal world, main will be a program driver. There's nothing magical about calling this rectangle driver. You know, I could call it Ethan. The program would work okay. But typically, if you've got a class like rectangle, you call the program with the driver in it, rectangle driver. Okay? Now, I'm going to actually put this in. It's going to look a little weird, but I'm going to create, let's see. I'm going to create 3 of these, and they're all going to look a little different. I'll put in here 10, and I'm going to create one more. Now, if you look up on the screen here, what you'll notice is I don't have an error for the first one, and I do have an error for the other 2. See that? Because even though I didn't write this, if you look, I'm going back to the rectangle file now. Even though I didn't write this, what's going on with that? But that got written for me automatically. So when you write an object-oriented program, all right, like we've done, a constructor, which is what that is. This constructor, just so you know, this is typically referred to as a no-arg constructor. That means there aren't any arguments in it. That means there's nothing in the parentheses. That's why when we wrote this, okay, that's why we, even before we wrote that, it was already written for us. That's why we don't have an error. All right? So what I'm going to do, just so you see this, is I'm going to make a copy of this, all of this. All right? And I'm going to call this my one-arg constructor. This will be a double, and it'll have H. Let's say we're just passing it a height. Now notice that once I've done that, please look up on the screen. Now notice that one's not in error anymore. All right? I'm going to do it one more time. And I'm going to call this my 2arg constructor, double H, double, double, W. All right, so now what you notice is no errors and no errors. I have 3 different constructors that I've written. Somebody tell me, what's the difference between these 3 constructors? The arguments. This whole thing right here, just so you know, this right there, that's known as the method signature. The method signature has 3 or 4 things in it. For a constructor, a method signature has 3 things in it. It has what's called the access specifier. It has the name of the class, and it has the arguments. As long as I have different arguments in here, I can overload this as many times as I want. So if I was setting 10 different things, first name, middle name, last name, height, weight, etc., 10 of those, I could probably have close to 100 different iterations of constructors. Now, I want to show you something because sometimes people get confused over this. All right? What if I just did this? Why doesn't that work? They have different names. It's because the compiler doesn't care squat about what you name anything. All it looks at, putting this back to the way it was, all it looks at, come on, there we go, is nothing, double, double, double. It does not look at the names of the parameters. It looks at the types. All right? It's a really important thing to realize. So when you create a constructor, all right, the constructor says public. It looks almost like when we did the class. But here we say public class rectangle. For the constructor, you leave off the word class. Constructors can, you already saw this, can have things passed into them, but don't have to. Just so you see this, look up on the screen here. This line right here, line 11, and this line line 18, this is what's called an overloaded constructor. Later, we're going to talk about overriding. There's 2 different things that you can do in object-oriented programming languages. You can overload something, you can override something. This is overloading. When you overload, all right, you give methods different, all right, different things in the parentheses. You know, we didn't do this, but as an example, what if I did this? I just want you to see it. This is not going to be pure Java that I'm writing. I'm just going to throw something out there for you so you see it. All right? And that is, I could write this, public int add 2. You've seen me write things like this before. Int n1, int n2. Return n1 plus n2. All right? I could do it again, and I could have here double add 2 and have that be a double and have that be a double. And in the first time, I'm adding 2 integers together. In the second one, I'm adding 2 doubles together. All right? You know, if you say, could I have another one where I had an int and a double? Yeah, but you're asking for trouble doing that. But yes, you can. This is an example of an overloaded Java method. All right? What's in the parentheses has to be different between the 2. So if I made this, even if I kept that as a double, but I made that an int and that an int, I'd get an error. All right? So we now have 3 different constructors. One constructor that expects nothing is in there. So what am I going to do? I'm going to say this dot height equal 10. This dot weight equal 10. I made those numbers up, not weight, it's length. All right, I made, it's, what is it? Isn't it length and width? It's height and width, sorry. Width. All right. There's nothing special about those number 10s. I just made them up. All right. Here, we're going to say this dot height equals h, and this dot width, I'm going to give it a default value, equal 10. You see the difference? In the first one, we're not passing anything in. In the second one, we're passing in a value. But then we still have to account for the other value. All right? Now in this third one, go down to that one in just a second. It's going to look like that. And if you can wrap your head around that, you're on your way to be able to understanding this. All right? I told you before that most people equate a class to a blueprint, okay? But a lot of people have a hard time understanding what a blueprint is. Another way to look at it is when you create a class, it's a template. You're creating something so it can be used. All right? So again, if you look at this, now, just do me a favor, just please, everybody, look on the screen here, because I want you to play computer. So if I go and do this, I'm creating a new rectangle. It's called R1, and I'm passing nothing in. So it comes over here, and it says, oh, here it is with nothing in there. So it's going to automatically set the height and the width to 10. Does that make sense? So us doing this basically is doing the same thing as if we did the last one. All right? This, passing in, now it's going to look and it says, oh, do we have something where we have a single numeric value passed in? And it says, yep, that's this one. So it's going to set the height to that value, and it's going to default the width to 10. All right? And then finally, in the last one, it says, oh, we're passing in two numbers. Do we have a constructor that has two numbers? Yep. Now, you may or may not realize this, but one thing we are not doing right now. Do you hear my words? One thing we are not doing. We're doing no validation. We're going to have to do validation. All right. Right now, we can put in negative numbers, for example. I don't know how you would have a triangle that, or a rectangle rather, with negative numbers. Okay. But it's legal in what we're doing right now, because you can have, in fact, we could have doubles that were humongous. Okay. We're not going to, but you could conceivably do that if you wanted to. This now is an actual working class. Now, if we go and print stuff out, it's not going to probably print out what we think it is. Okay? In fact, I want to show you that. If you don't look on the screen here, I'm going to come out here and I'm going to say system.out.println R1. Why does it like that? Cannot resize. System.out. Oh boy. All right. System.out. Yep, you're right. We need a main. In fact, this whole thing that's right here should be in main. Thank you. PSV. All right. Thank you for saying that. You are correct. All right. We should have taken all of this and put it in main. Now it'll work. All right. System.out.println R1. What is it? Just S? S-O-U-T. Okay. All right. So I can put in R1 and R2 and R3. All right. So let's just save this. I'm going to do a save all and run it because I want to see what happens. I know it's not. I probably won't get an error, but but it's not going to give me the output that you think is probably that will go. That the output we get is probably not the output you think we're going to get. All right. See this? It gave me this, and it gave me this, and it gave me this. For lack of better words, look at it. Those are the addresses in memory where those things live. All right? When I want you to hear this, but please don't look at me. I don't care where you look, but listen to this. When you call the routine system.out.println, what Java does is it calls its own method that's called ToString. You know what ToString is. So we've already done an override on the constructor. In just a minute, we're going to do an override on the ToString method. All right, in fact, we can do that right now. Let's go back into our class, and we'll go back on the bottom, and I'm going to put this on the bottom because this is not a getter or a setter. So I'm going to come down to the very bottom here, and I'm going to put in public string ToString. I don't think I have to pass anything in. I could be wrong, but we'll see. All right. And right now I'm getting an error because I'm not returning anything. Okay. I'm going to do this. I'm going to say string output string equals nothing, and then we're just going to keep building it. Output string plus equals height equals, we're just going to put this in here 3 times, or we'll put this in here twice. That's fine. We'll just do it like this. In fact, we can put it in there 3 times. So you've got the height. It's not height, it's length and width, right? It's height and width. Height and width. And we'll have area. All right. Now we've got to put more in there than that. Plus get height. Okay. Oops. I need paren there because it's a method. Plus get width. All right. And plus get area. All right. Now, when we call this, when we get done, all we want to do is we want to return that output string. What we have done right here is we are telling the system when you call system.out.println, when you call that, call this. All right. Now, for it to make some sense, because I don't want every one of these to print 100. Everybody hear me? That would be stupid to make them all sick because they'll all look the same then. I'll make this 20, and I'll make this 30, and I'll make that 30. All right? So, I'm going to call system.out.println, and I'm going to pass it in R1, R2, and R3. I don't know what it's going to print. And it still printed the same thing, so why did it do that? Yep. See that? Now I didn't put in new lines. Okay. So all we have to do is put in new lines right there. So yes, not only can you see it, but we're going to do in just a minute, we're going to finish this. We're going to take another break after we do, and then we're going to go and do this thing for payroll, and it'll probably make more sense than this. All right. But let me fix it first. So where I have all this stuff, because that's printing out really ugly like, what I probably should do is this. Okay, just instead of these system.outs, they're fine. But in here, I should put in a \n before each one of these. You know what a \n is. It's a new line. And in fact, when we get done with the area, let's put in another \n. Okay? And I'm just doing this for formatting reasons, for aesthetic reasons. Okay? I'm changing, every time I teach a class, I change it. One thing I'm doing this semester is with you guys, I found out if I didn't force you to do something, usually you didn't do it. All right? And that's human nature. I think I'm the same way. So they're having their first test in the C# class tomorrow, and I'm telling them part of their grade is you have to use the naming conventions that we learned in class. You have to use some of the properties that we learned in class. And if you don't, I'm taking off. That's the only way I can force people into doing that. All right. Now, before I give you that, and I will, like I said, in just a second, I want to do one last thing. So I want to print out in here. Now let's run it and take a look at it. So now, rectangle R1, I guess I didn't need that extra print line, but you can see it, 2 and 3. So this had the defaults because I call this with no arguments. So it defaulted to 10 for each one. Here I passed in 20, but I didn't pass in a width, so it defaulted to 10, and it gave me 200. Here I passed in both values. All right? One more thing, and then I'll go back to it. Leave it like that. It's fine. All right. What I'll do when we get all done with this, I'll print out 8 copies. These are not very long. So if you want to look at it, you'll be able to look at it. All right. And you'll be able to use it as a template or whatever. Notice how small 15 lines this driver is. 15 lines. All right. Even the actual program itself, 75 lines. So I've got a program and a driver for it, and the whole thing is under 100 lines. So again, I'll print these out for you in just a minute. Let's finish this first. So, classes, a constructor is a method, but it's a special method that gets called when you instantiate or new a class. It automatically gets called. All right? Constructors are typically, you use constructors to perform initialization. Now, is that important? Heck yes, it's important. Again, please look up on the screen here. When you are working in this language and you create these variables like this, do not ever initialize them. You initialize class variables and instance variables in the constructor. That's what the constructor is for. Do not initialize them here when you create them. It's considered very bad practice. You will initialize those variables inside of the different constructors. Constructors have a few special properties. You already saw this. They have the same name as the class. So the name of the constructor is the same name of the class. They cannot have a return type. You can't even say public void, or you get an error. They may not return anything. They're almost always, I don't know if I've ever seen a constructor that's not public. Okay. So here's the constructor they made for the rectangle class. It's one of the three that I made. All right. There they are in UML. We don't care. All right. Now, when you do this, if you create something, that's like if I did this. Again, I'd like you to look up on the screen because this is important that you at least hear this. If I did this, like that, just R4, sorry. If I did that, now the value of anything that might be in that rectangle, anything, it's null. It has not been set. That is an example of declaring a rectangle object without initializing it. All right? And in Java, now if I came through here with just like this, and I put in this line, you think that's going to work? All right, I think it's going to blow up, and it's going to give me what's called a null pointer exception, which means I'm trying to print something and there's nothing to print. All right, I'm not sure if that's how it's going to handle it or not, but that's my guess. Well, it's telling me there were errors. Compilation completed with one error. All right, it says, hey, error, variable R4 might not have been initialized. The program blew up right there. It didn't know how to handle what I was asking it to do. All right, and the only reason I'm telling you that, I'm not trying to waste my time or your time. I'm going to comment this back out so it works. But it's the same, it's the same thing as if I did this. You know, you've seen me make programs where I'll say like int age equal 21. You've seen that before. But if I just did this, and then I came out and I typed in system.out.println age, I'm going to get the same kind of error. Because when you declare a variable and you don't give it a value and you try to manipulate that variable, it's got a value of null. And the system doesn't know how to handle null. Null means unknown. Say, oh, it means 0. No, it doesn't. It means unknown. Notice here I'm even getting an underline, and it's telling me variable arg might not have been initialized. And you can say, wow, it did that, but why did it do it for this other one? Why didn't I get that error there? Because it's possible to initialize an object in different ways that you can't do typically with a regular variable. Again, that default constructor is what I called a no-arg constructor. Notice what it does. It sets all numeric fields to 0 for you automatically. It sets any Boolean fields that you have to false. And virtually anything else gets set to null. All right? Even if you don't do it, it's done for you. The only time Java provides a default constructor is when you do not write any. Guess what? We've never written one before today. So it's always provided a default constructor that didn't do anything. You can build your own no-arg constructor. How do I know that? We just did that. We also went in, and it says one of the string class constructors, yeah, we went in and I just showed you how to go in and override the ToString method. And I showed you what happened in our case if we didn't override it, that it gave us that address that started with an @ sign or something. All right? Now, one thing I want you to understand, if you please look up on the screen here. If, I'm not going to do this, I get an error anyway, but if you do this, if you pass those two things in there, it makes a copy of the 30 and passes it. It makes a copy of the 30 and passes it. Right now, this 20 and this 30 and this 30, they're all passed by what are called pass by value, which means it's passing a copy. If I were to, and I'm going to get an error for doing this, but if I did this, okay, I'm going to get an error. But the point is, if you pass an object as a parameter. You don't pass a copy. You pass the address in memory where that object lives. So if you make a change to an object in a method, it's a permanent change. Always. That's how Java does things. Many other programming languages do it like that as well. Now they say this is method overloading. Guess what? I showed it to you. I didn't like particularly the way the author wrote this, so I just showed you myself. Okay, there's very similar to the one I showed you. I called it add2, but there's 2ints, etc. All right. I told you already what a method signature is and how when you overload methods, the method signature has to be different. Technically, even though they say that's the method signature, yeah, technically the whole thing is also referred to, depending on the book you read, as the method signature. But what's in the parens has to be different. Right, so there's the overloaded constructor. And they're saying this one would call the no-arg constructor, this would call the constructor that expects 2 doubles. All right. Now, I'm not going to go over this because they don't do it in much breadth of coverage here, but I will tell you, I could change, but there's probably a pretty good chance that the program that you will have for your next test will be probably something like a bank account class. Something along those lines. I don't know if it'll be a bank account or not, but it might be. Okay? So if you had a bank account class, well, what would you have? You could have a bank account with no starting balance. I guess it's possible somebody just walks in, opens up an account, gives you the information, or does it over the phone or online or whatever. All right? But usually you're going to have some kind of a starting balance. All right? Notice what they have here in this bank account. They have 3 different constructors you can have. One with nothing, one with a double, one with a string. We've got 2 different deposit methods. So now we're overriding another method. The deposit. And we're overriding the withdraw method, and we're overriding the set balance method. This is true object-oriented programming. You do a lot of method I shouldn't even say overriding, I said before. It's overloading. You do a lot of overloading. And it's all contextual. So you do it based on whatever it is you're trying to do at that time. All right? We talked about public. Okay, this is a little confusing. They talk about shadowing. It says a parameter variable is, in essence, a local variable. Let's just talk about what that means. All right? Now, this is something that you should never do. In fact, I'm going to get an error because of the way I'm going to do it. But if I came in here, okay, in this one, we did this double H. If I come in here and I create a new variable and I say int height, notice I don't get an error. And it's like, wait a minute, you already had a height up here, and that's height. Wherever it was. Where did I put that? There. This is called shadowing. If I create a new variable with the same name as one of my other variables, since it's local, it's a brand new variable that's only known in this method. It's what's called shadows the other one. All right. What if I wanted to use the other height? What if I actually wanted to use the height of the program? Now this is probably going to give me an error. Yeah, it won't take that. But you're going to find as we get into this more often, a little bit more, you use the word super. All right. Super, for lack of better words, typically means, hey, I want to work with a parent. Okay? That's the generalization, but that's usually what it means. All right. The more things that we add in here, the more import statements you're going to find. All right? Some of the Java packages, we will look at some of these. You've already looked at a few of them. Colin asked me yesterday, how do you get the random number? And I said it was under java.util.random. All right, there's one of them right there. JavaX.swing, we've already looked at that. That's got our J option pane stuff in it. When you do database, it's java.sql. If you work with network communications, if you're on the hardware side, it's java.net. For working with files, it's java.io. I don't want to confuse you now, but when we're almost done with the Java section and we start building a couple GUIs, we're going to look at the difference between the AWT and swing. Okay? They both work to help you do GUI stuff. That's all I want to say about it for right now. All right. So they're saying here, what is object-oriented design? Somebody writes down a set of requirements for you. They say, hey, Dominic, I want you to do this. Dominic goes through what they want him to do, and he starts to underline all of the nouns. You know what a noun is, a person, place, or thing. But it can also be a concept. All right? And those will possibly become your classes. Then you look for the verbs. Those will typically become your methods. And anything that's specific, like class might be, not class is a rotten word, car, for example. All right? Car will probably end up becoming a class. Ferrari will become a class. Or Ferrari might be just a car object. Okay? Then you identify what you want each class to do. What do they have to know? What do they have to know to do? How, basically, are they able to go back and forth and communicate with other classes? All right, so you find the classes, you identify the responsibilities. That's it. So I will print this out right now. All right, it's a little early, but what we'll do is we will start. I'll go till about 2:20 or so, then we'll take another break. All right, so I will print this out right now, what we've done. This should all be working. Everything that I've done should be working. All right, so we're not going to worry about that right now. When that all gets done later, after the break, I'll go over there. I've got a bunch of other stuff in there, and I'll give everybody a copy of each thing. So if you want to look at it, you will be able to. What I did again was I basically just rewrote the same one that's in Chapter 6 of your book. All right, and when you think about it, you are all to be commended, and I'm being serious here, because when you look at this, we're already 350 pages into a 950-page book in a week. All right. By the end of next week, I hope we get through Chapter 9. So we do 7, 8, and 9 next week. We'll see how it goes. All right. Then we're done with a lot of the big stuff. All right. All right. So I'm going to come in here, and I'm going to do, as I always do, my file, save all. All right. Now, I asked you to do this the other day. You may have done it. You may not have. But I asked on your desktop, under your payroll folder, for you to add a payroll OOP1. All right. Hopefully you did that. And if you didn't, please do that right now. All right. Because we're about to create payroll OOP1. So I'm going to go in here to IntelliJ, and I'm going to close the project that's open, and we're going to create a new project. All right, you know how to do this now. Next, next. This one is going to end up being called payroll OOP1. Finish. I'm going to right mouse click on my source file, do a new Java class, edu.rankin.jpscott.payroll. Okay, I'll give you a minute. Would you please do that and try to get caught up like that? All right, I'd like you to be there. Now, I don't want to confuse you any more than I maybe already have. All right, I don't want to confuse you, but when we write this, we're going to write it in a certain way. Everybody hear what I'm saying? We're going to write it in a certain way. After we do that and we get it to work, we're going to kind of rip it apart and say, well, could we do this better? What I'm going to do, and what I suggest you do, when we do that, when we go and rip this apart and kind of redo it, I suggest you take the stuff we put in there at the beginning and you comment it out, but leave it in there so you can see the difference between these two ways that we're going to do things. All right? Everybody able to go in and start up a new project, a new payroll project? Yes? Any problems? All right. Let's just go in and we're going to do nothing right now but create our variables. All right? We'll create our variables because there's quite a few of them. And to keep this simple, okay, we're going to have to do very little as far as local variables. The majority of everything we do here is going to be global. Now, one thing we haven't been doing, and it's never a bad idea, is at the top here, I'm going to come in and put in a comment. Try to explain at least what we're trying to do. This is another Java payroll program. It will demonstrate concepts such as classes, getters, setters, and overloaded constructors. And an overloaded ToString method. That's it. Now, you're not turning, well, you are turning this in, but this is another one you'll turn in. I don't really care that much if you put in a comment or not. But again, as you all know, the time to comment is when you are creating something. Anybody who tells you, oh, we'll go back and do the commenting when we're done, probably will never comment. That's just how it works. First thing I'm going to do is, we all have that comment? Yes? All right. I'm going to come down here and I'm going to declare, not del here, and initialize my program constants. And guess what? You know what these 6 are already, the same ones. We're going to have max non-OT, OT rate, min hours, min rate, and max rate. All right? And since I'm going to have 6 of these, I'm just going to copy this 6 times. And then start filling in the stuff. Put 1 space there.
Do we need static?
No. You can put it in there, I think. I didn't. I don't know why you couldn't, but no, we will not need static. In fact, to my knowledge, we won't have the word static in here, in this file. Okay? Again, please don't be copying all this in, especially those of you who don't type fast. Do as much copying as you can. Put in the first one, copy it in there 6 times, and just make the changes. That's got to be rate. Thank you. We'll put the max rate at 100. It doesn't really matter what you put it at. All right. So those will be our 6 program constants. Next, we will have 5 instance variables. And I tried to cut down even on the names. So instead of hours worked, I just called it hours. Instead of hourly rate, I just called it rate. Instead of gross pay, I just called it gross. All that makes sense? But you should be able to see what goes with what. And again, please look up on the screen. These are instance variables. You do not initialize instance variables when you declare them like this. So I shouldn't even say declare and initialize. This should just be declare program instance variables. We're not initializing. Now, Colin, you just asked a question, and when I gave you the answer, I lied to you. Not on purpose, but I lied to you. The next 2 variables we put in here will be static, because we're going to have the total gross. We want the gross of all of our employees put together, and we want the total number of employees. All right, when we get done with this program, and I have every intention of us getting done with this by 4:30 today, all right, when we run it, there's an error right now. And Jeff beat his head against the wall before, almost literally, because he knows what the error is, but he can't figure out why he's getting the error. All right, so I'm going to let you look at it, because might be one of those things where, I even may look at it and go, it's just this. And I'm like, oh, geez, I don't believe yeah, okay. The problem we're going to have, just so you know, is whenever we do the gross pay, it's going to count how many employees we have, and it'll be correct. But our gross pay is actually going to be double what it really is. I'm not sure why, but we'll figure it out. All right. So I'm taking it that everybody at least has these. Okay? So now I'm going to bring those so they're up here. Now I'm going to, this is what you talked about, Colin. Declare and initialize what are called class variables. These must be static. All right? So, private, static, int, count equals 0. That's going to be how many employees we have. And private, static, double. And we're going to call that tote gross. Tote gross. We're going to set that equal to 0.0. All right, I'll give you a second. We're going to put in 2 more lines, and then we'll be done for now. Okay? What we have to type in, it's not terrible. It's a little over 3 pages. We've already got almost 1 page done. Okay? Now, if you look up on the screen, everybody just stop what you're doing for a second. The reason these 2 have to be static is every time I create a new employee, I will now be adding to the same counter that's called count. There's only 1 of them. Remember I said static implies 1. If I left the static off of here and I made 5 employees, there would be 5 different counters and each of them would have a value of 1. It's not what I want. I want 1 counter with a value of 5, not 5 counters each with a value of 1. Since I want them all to be able to share the variable, that's why I make it static. So that it implies, again, there's only 1. If I left the static off of total gross, then it would only give me the total gross of the last employee. I want it to be all employees, so it's static. All right? The other thing we're going to do is we're going to make a couple of of decimal format objects. Why? We don't have to do it this way. We could have used that system.out.printf that we did yesterday, but I'm forcing you, by doing this, it's another example of you seeing object-oriented programming in action. All right? So, decimal format. All right? Yeah, we want to use that. Remember this? It's giving me an error, so it's saying if I put my mouse here and I hold down on the Alt key and I hit Enter, all right, oh, it should, Alt, Enter. It says, what do you want to do? I want to import that class. You either have to manually type this in at the top of your program, and it has to be under the package statement, but before the class header, or you have to do it the way that I just did it. So it's import space Java space, or I'm sorry, import space Java period text period decimal format, and it uses Pascal casing, meaning the D in decimal and the F in format are both uppercase. All right. So we're going to create two new decimal format objects, and we'll call this F1 for format 1, just so it's simple, equals new decimal format. Move this way over so you can see everything, okay? And this one will have a $sign in it because we want the person, what they're making per hour and their gross, to have $signs in them. All right, so this will be look like that. And then again, please look up on the screen. Don't type anymore. Copy this line. Why? Because all we want to do is make it F2, and we want to remove the $sign. If you keep typing and typing and typing when you don't have to, you're wasting your time. All right, so from the top, we had our package statement for us automatically. We imported java.text.decimal format. Underneath our class header here, we created 6 constants, all of which are doubles. Our max non-OT, our OT rate, our min hours, our max hours, our min rate, and our max rate. We declared our instance variables, and there were 5 of them. So every employee will have a first name, a last name, an hours, a rate, and a gross. Does that make sense? I could have added stuff like social security number, etc. I didn't, but we could have added that. When you do your next test next week, either you're going to write your own class, something like a bank account class, or I'm going to have you manipulate this one. I don't know yet. All right. Then we came in and we did our class variables. These are shared. Then we came in and did a couple decimal format objects. So that's where we are right now. Good time to do a file, save all. It is 2:27. Let's come back at about 2:45, please.